Hello. Welcome everyone to another amazing episode of Angular Air. My name is Alyssa Nykel. I'll be hosting for you today because Shorty, he's a bit down in the nasal passages, but he's still with us. You know, he's not down and out. So, but I'm going to introduce our co-hosts, and then we'll get into the guests and the topic for today. So, welcome, Shorty. I already did the best intro for you ever.
Thank you. Yeah, trying to keep smiling through being sick, but yeah.
At least you live in like a really lit house, right? Like, so
I
like
mean,
just
there's lights, so yeah, and
and
I think it's fun.
I mean, it is. Is the rest of your house though like cool lights and automated, and or is it just this?
Now, why would I reveal that?
Oh,
No, it's like a mess. The rest of the space, this is a mess, but this is all dialed in, right? Because this is on camera, right?
right. Yeah, no. I just imagine you like walking down the hallway and there's like flashing purple lights and things. Like, yeah, like a runway.
Actually, that's the dream. I haven't gotten there yet. I've been thinking about that. Well, just strips everywhere and just
How
lighting
does
it up. Yeah.
the other person who shares your residence feel about this dream?
I think we all wouldn't mind, like, walking down a runway every once in a while, kind of like, showing the fashion and stuff. So just
when
life would
you
be
achieve this, we're gonna do a walkthrough of your house on air, just to like, really.
All right, yeah. Live stream from my phone or whatever.
Hi, Christoph. Hi, Coder Hub and Tran. Good to see you all in the chat. Also with us today, we've got the beautiful Mike, who's this direction of me. Welcome, Mike. How are you doing?
Not too bad. Debating leaving to go walk down my hallway like it's a runway, but other than that, doing well. I also like the intro. I've been escalated. I used to be a panelist, but now I'm a co-host. I like this.
Oh, that's the noun. I couldn't come up with it.
No, I'm good with it.
Panelist. No. This is the new Angular Air, new 2023. It's all about we're all hosts.
Co-host.
So, yeah, so this is the perfect time to break it in.
Ashik. Hi, Ashik. Sorry if I mispronounce handles. I'm like the literal worst. It's good to see you in the chat. All right. So our guest of honor, our most honored guest with all the wisdom to share to us today, Chau Tran. Hello, or narked on the socials. Hi, how are you doing?
Good. How are you guys?
Oh my goodness. So good now that you're here. I was pumped for this episode.
Thank you. I hope I don't disappoint.
Oh. Okay, introduce yourselves for those in the community who are like, who is this Chau? Right?
Yeah.
Tell us a little bit about yourself.
So, hi everyone. My name is Chau. I'm a senior engineer at NX, an Angular developer expert, and I consider myself but I still am on paper a core team member at Nest.js.
Okay.
Yeah.
Very cool. What? So wait, you consider yourself, and you still are on paper. Is Nest not doing good? What's up with Nest?
I haven't been involved with the project for close to 2 years now.
But it's not like dying.
It's not
people
dying.
Still use
right?
It.
Yeah,
Okay.
people still using it, and like the core team actually, the core team is really working hard on Nest.js. It's just that I don't work on it.
Sometimes like tools like die, and then people are like, Alyssa, why are you still using that? So I just thought maybe you had something to let me know. Like, it's still going good. People can use it. Cool. So, Chau, tell us what we're going to be talking about today on Angular Air.
Yeah. So today we're going to be cracking the Angular renderer. So it's a niche topic. So,
and I guess Mike has a fun nickname for it. I just wrote it.
I was just abbreviating to R. I wasn't going to say that because you used an interesting pronunciation for the R word. So I was like, I can't do that, so I'm just going to call it the R.
Oh. I see. Okay, I'm with you now. You're not trying to be a pirate on this lovely Friday morning. Okay.
But I am unfamiliar with cracking in this context. What does cracking mean for the renderer? I said it.
We will try to understand what the renderer is doing.
Like cracking it open, like you're revealing its secrets. Mm-hmm. Like it's a little egg, and you got to give it a good crack. Like, Christoph was asking in the chat too. I don't think we're trying to kill the renderer.
No, we're not.
Okay, cool. Just good clarification. I love it.
Yeah.
So we're working on understanding with the tools that we're using.
Yep.
Perfect. Love it.
Oh, awesome. All right. Well, without further ado, if you have anything to share, let us.
Yeah, I have a slide and I have a light coding. I'm going to let you guys know when I switch between the two.
Excellent. All right. Also, hello, Quate. If I said that right. Good to see you in the chat. Good to see you. I'm going to try to say hi to everybody who enters, but forgive me.
That is a big task. You can do it, though. I know you can do it. All right, chat. Everybody say hi. Like everybody.
But okay, but only the easy names to say hi. If you have a hard name, don't say hi to me. Mike, you don't count. All right. So Angular renderer. Let's dive in. I'm excited to learn. Do we have slide?
Yeah, I do. So I just start by sharing. Hit present on StreamYard.
Okay.
Let's see if we can do screen. There we go. All right. Shall we start?
Let's do it.
All right. So again, hi everyone. We're going to try to crack the Angular renderer today. As I mentioned, it's a niche topic that might not serve you on like a daily basis. So we do get in some technical of the renderer. So I hope you learned something today. I'm gonna skip my introduction because we already did that.
Oh man, you had a cool asset and everything to go with it. You can redo now. I didn't know.
It's okay. So that's my Twitter. You wanna
and do
follow?
I say your handle right? Is it Narc?
It's not. It's Chau Tran backwards.
Oh my god, I never knew. Did you all know this?
Yeah. I mean, it's common. No, I didn't know.
That is so cool. You like when there's like Easter eggs in life like that, I just get so excited. So thank you for that. Okay.
Yeah. And that's my GitHub. Also, all of my open source works is going on my GitHub. All right. So first, what is the Angular renderer? So for some folks, this might be what we mean when we mention Angular renderer, right? This, when you inject the renderer 2. Disclaimer, I don't know what renderer 1 is or was. When I first started with Angular, this is all I know. A renderer 2. Nice. I don't know if we have renderer 3 or not. There's one in the code base, but we never actually get to use it.
Wait, there is one?
There's one renderer 3 in the code base right now. I think that's the Ivy, but we don't interact with it.
Okay.
Yeah. So if you worked with Angular for a long time, like pre-Ivy days, and I guess most people here have worked with Angular for a long time, you've probably seen something like this. When you want to manipulate the DOM, so you have like an element either by view child.
I constantly want to manipulate the DOM to my husband's dismay. So yes.
Yeah, you have like view child, content child, or like dependency injection. So to interact with this element, you would inject the renderer 2 and use the methods on the renderer to interact with this element. Like right here, you do this .renderer set attribute. So these methods did have something to do with Angular core back in the Vue engine day. So it was to ensure that the element being manipulated was still working after the fact. Nowadays, you don't need to do it anymore. As early as post-IV, so Angular 8, Angular 9. With IV, the renderer touches less of the core, which we will see in a minute. You can just manipulate the DOM element directly using the DOM API. You can just do native element, set attribute on this native element. All right, so why are we talking about the renderer today? Isn't it relevant? Well, the example only shows how you would interact with the current renderer, but it doesn't really show how like the renderer plays in the life cycle of a component or what exactly the renderer is underneath. Have you wondered what provides the current renderer? Anyone?
Mike, why are you so adamant about this? Yes, it keeps me up at night.
Where did you come from? Where did you go?
Yeah, the renderer cannot just be there, right? You can
Absolutely.
inject. Yeah, you can inject it. So something must have provided
Did
it.
you just call the renderer Cotton Eye Joe? Is that what you just did?
I think he did. I think he did.
Maybe we'll
Inspired.
go with maybe. I don't want to
It's
claim
totally-
anything.
Okay. Also, hello to Daniel, Jerry, Christoph Fritz, Mary Day, Guillaume, and I think that's all.
Yeah. Hi,
I'm
everyone.
gonna do it.
Welcome. All right. So if you look into your main.ts file, you find something like this. If you're working with standalone API, then you see Bootstrap application from platform browser. If you're stuck in the past and still using ng module, you see something like platform browser dynamic. But the point is there's platform and then there is browser. If you're working with native script Angular, you find this in your main.ts file or any other entry point, right? Platform, native script. And if you're a curious Angular developer, you find something like this on the internet, platform terminal. And by the way, I would highly recommend checking out this repo in the README.
Yeah,
There's a very
this
cool screenshot.
Okay.
Yeah. So those platform functions are what provide the renderer. And so in a sense, the renderer is what makes Angular core platform agnostic. So yes, Angular is platform agnostic. Now, disclaimer, I know there are curious individuals in the chat and those that like look at the source code, Ania. There are some hard-coded DOM-related code in Angular core, but I would argue it's still platform agnostic. But for today, we're just focusing on the platform browser.
So that's what you mean by platform, because you mean like where it's being shipped.
Yes.
Like,
so
okay.
you will always see.
Hold on, wait a minute. I
Yeah.
thought at one point you were saying like framework. No, you're not saying that. You're saying it's like whether it's
Platform.
mobile or whether it's desktop or whether it's. I gotcha.
Yep.
I gotcha.
And even not just like separate platform like that. Even on the browser, you have WebGL, right?
Okay.
Or the Canvas. So you're still on the browser, but it's a slightly different API that you have to interact with. So here, I just have a simple component, app component, right? And let's just focus on the template. So we have a div with some text, and we have a component, parent component. So the component template then goes through the Angular compiler, which spits out the template instructions. For those that don't know, these are the Ivy Engine template instructions, and we're going to take a closer look at some of them. The template instructions call into the renderer, and finally, the renderer interacts or represents the platform. So in other words, you can say that the renderer is the bridge between your template, the template that you write, and the platform that you're working with. You can also shrink the diagram down to Angular core and the platform. So Angular core is the part that deals with chain detection, diffing mechanism, updating bindings. So notice that I don't use the DOM here because we can have platform agnostic. So like property bindings, event bindings, all of those, how they interact with the platform is the Angular core responsibility. All right, here is where we get a little technical. So this is what the app component gets compiled to after compilation or ng build. This is built with development configuration so that the code does not get minified. Let's focus on the template part again. So this is the template function, which contains the template instructions. So you see element start, text, element end. So the template functions expects RF, which short for render flags, and CTX is short for context. So render flags has two values, create and update. They are representing the creation phase of a component. Creation phase of component is when the component is instantiated. So when Angular calls a new app component, set up all of these dependencies and the inject the context for this component. And the update phase of the component, aka chain detection, runs, right? When you search online, when you search on Google, you will always see the phase of when the first chain detection cycle runs, when the first render cycle runs, right? So people refer to this, but it is actually update phase of the component. Expression change after check, right? That's the update. That's the update phase of the component. And then we have the context. It is the component instance. So a component can be rendered multiple times. So the template function needs the exact component instance so that it can operate on the correct methods and properties of the component instance. All right, we're good so far?
Yeah.
Great explanation.
All right, let's remind everyone of the template that we write in app component. Now, there's one thing that I want to emphasize. If we look at the template that we write div with some text inside of it. We know subconsciously that we refer to the HTML div element of the web browser API. So now look down to the template function. I mean, again, I think I can like annotate, right? So right here, we look right here. There is no indication whatsoever to tell the template function that this is an HTML div element. To the template function or to Angular core, this is just some element with div as the tag name. If we go down 3 more lines, same thing with app parent. We know that we refer to parent component, but there's no indication to the template function that this is a parent component. It's just an HTML element with app parent as the tag name. So this might kind of like, if you think about it a little bit more, it might make sense why we have the host element of the component. We always have that host element when we have a new component, right? When we render a component. Let me remove that.
I was gonna say we can like be like, no thanks, right?
Right. So now, so these are the template function, the current template functions that gets generated for the app component, current template. Now let's take a closer look at element start. So this is the code of element start in Angular core. Accept some parameters, index, name. If you look down to the template function again, you see that our index is 0 and div is the name. And this makes sense because div is the first element on our app components template. So 0-based index, right? And then element start does something at the beginning. And then we get the renderer from the L view. I think this is the environment injector, the environment, the platform. Then it calls create element node with the renderer and the name, which is again the div. Create element node finally calls renderer create element name. Let's pause for a moment here. Does anyone see something familiar or feel something familiar or similar? Well,
renderer looks like document.
Yeah, that's true. If you ever create like an HTML element dynamically, like maybe for dialog, modal, script tag, what have you, you probably use this API, document.create, and you pass in the name of the tag of the element you want to create. So now this is where, this is the first time where the Angular core knows that div refers to HTML div element. So this is thanks to the renderer and platform browser. Right, so that's this element start. Ultimately, this template instruction tells Angular core how to create an element with a tag name, and that's it.
But it's at that time, but even though the renderer is essentially marrying the idea of the DOM to what needs to be rendered, Angular core has no concept of the DOM at this point. It's just, hey, I need this thing to be rendered, and I'll let you handle it. You do handle that association. You know how to create this thing that I'm telling you needs to be created.
Correct. And you can imagine inside of this text, instruction function, it's going to call into the renderer to say append the text onto the div parent, the parent div. So all of the interaction with the platform is the renderer. All right. So now, in addition to like creating the element, we do have some common concepts like property binding. Right? So you have a property name, some square brackets, and then you bind some expression to this property. And I'm not talking about input. It's just simple property binding, like you buy to like an ID, right? Or you buy to like a label or a title, what have you, on the HTML elements. Next, we have attribute binding. Technically, this is not a binding because there's nothing to bind, but I want to keep it consistent. So here we have some attribute name and some static string value. Last but not least, we have event binding. So we have parentheses around the event name. We bind the handler to it. So to reflect that, I update the template of our app component with property binding. The title property on the app component, I bind that to the ID. Then we assign my title string to title attributes. Sorry, I have zero creativity. Just use title. Finally, we have click event, and we bind onClick handler to it. And we end up with this updated code for our app component. So let's bring that template back. We have a couple new template functions. First, the attribute binding gets added to the const array. So const sounds like something constant. It makes sense because attribute, both name and value, are in fact static or constants. Next, we have the click event, which generates a new template function, listener. So side note, this is one of the selling points of IV. So 3 checkable template functions. So imagine if you don't ever use event binding in your application, you never have listener function in your final bundle. So back to the slide. Here you see the template function refers to context.onClick. So again, context is the component instance. So we just call the onClick on the component instance, the method onClick. Finally, the ID property binding, yet another new function, property. Again, we see that context is being used, which is the component instance. Notice how the property binding is in the update phase, aka the RF check, the render flags check. Even though context title, the title property is a static string ng renderer, right? We still don't have property binding happen until the update phase or until the first chain detection runs. This makes sense if you think about when components inputs get resolved. You never get the resolved values of the components inputs in the components constructor ever. Or you always have to access the property, or I mean the inputs inside of like ng on init or ng on changes. We're gonna take a closer look at like these 3, like what they call in the renderer in a minute, because I guess I have to switch screen and stuff. Normally I would stop here and like show the code. I mean this like the code screen, but I would just keep going here.
So Guillermo had a really good question, and I know Mike answered it, but I wanted to address so the reason we don't use document to create elements in Angular has to do with internal order or execution or performance. And Mike said that it's because Angular allows for your app to be run in other platforms, as you mentioned in the beginning, not just the browser. So there might not be a DOM. But what if we're like, I am a web developer. I care not for you other platform peasants. And so does that like literally just give us permission to start throwing document around, or like, no, there's still other.
I mean, you still can, but if you know what you're doing, of course, you can still use a document object in your application code if you for sure this document is always there, right?
Okay.
If you do something like server-side render and you call the document object too soon and you do not use like dependency injection, then yes, you're gonna run into errors.
Okay. Yeah. Very cool. And hello, Vladimir and Cow. Did I say that one right? Ciao, Cow. Hi guys.
Hi everyone. All right. So here's the renderer 2 interface, which is like any renderer would have to implement. So far, we looked at create element. We're going to take a look at set attribute, set property, and listen in a minute. All right. Now we're ready to create a custom renderer. To create a custom renderer, we need a renderer factory 2 and the renderer. Well, now it's time for a demo.
Oh, it's so spicy. I'm excited.
You said now we're ready to create a render. I'm not ready. I don't feel ready.
Oh,
I already created it. It's all right. I already created it, but we're gonna iterate on that.
I like it. We'll stand on the shoulders of giants. You being one of the giants.
So people who want to do this is because like they're working with weird platforms the renderer doesn't support. Yeah.
Yes,
yeah?
absolutely.
Or maybe not weird. Maybe cool.
sometimes you just got to do something just to do something too, you know?
Yeah.
Like I have a renderer idea, so I want to ask about that at some point as well.
Yep.
Oh, okay.
And we will try with the time limit. We will try to actually have some like minimal working renderer that renders to the 3D WebGL.
This is so cool. I'm already like super impressed with like the wisdom you have laid down, sir. So
Okay, so I'm gonna stop sharing. I'm gonna reshare another screen here. Let me go to StreamYard if I know where it is. To present, share screen, entire screen, screen 1. There we go. Everyone see my screen?
Yes.
All right, so we're back to the app component code, and I have it running on the right-hand side here, right, localhost 4200, and this is my standalone component. If we look at the the page, is nothing much. This is it. And before we move on, let's look at that one of those, like listener property. So I'm gonna just take a look at this listener function, just copy it, go to core MGS, just look for it, and there it is. And it's calling to listen internal. Let's just look for that one. I haven't copied it, so copy that. Hide it real quick here. All right, just look for it. We find it right there. Oops, missed it.
I feel like I'll know that I've made it when I'm just browsing this file for fun.
There we go. This is where we call the renderer.listen. So again, event binding, like native event, right? Click, mouse down, mouse up, key up, all of that is handled by the renderer because renderer knows how to handle that. All right. So to just show that one real quick here. So right now we're running the default renderer. For our custom renderer, I create a file called render.ts. Of course, you can create anything you like.
Is this like in terminal? Are you coding in terminal right now?
Yes.
Because you're not impressive enough. God. Okay, keep going.
So as I stop. So as I mentioned, we have the renderer factory 2 here, and we have the renderer 2. To save time, I fill out this file ahead of time because you see like the huge interface of the renderer 2. You have to implement every single method inside of that. Now the renderer factory is an injectable, which means that you can inject stuff inside of it. In my renderer factory, I inject the DOM renderer factory 2, and this is a private API, by the way. It's from the platform browser. This is actually the default DOM renderer that when you do Bootstrap application or you do platform browser dynamic.bootstrap, this is the renderer this is the factory being used so that you can interact with the DOM. Now for our use case today, we're going to render. We use the Angular template to render 3D objects directly to the WebGL. Now, because WebGL is still part of the web API or the browser platform, so I want to have a way to kind of like extend the default DOM renderer because there are cases I might go back I'll fall back to the DOM renderer to do some DOM stuff instead of like the WebGL. On the renderer factory 2, there's a create renderer method that you have to implement, and this create renderer knows how to return a renderer. Why do we have this kind of like create renderer and not just the renderer itself? You know how inside of your Angular application you have view encapsulation, right? Shadow DOM emulated and native. I never changed that. I'm not sure, but really depends on the encapsulation. And those encapsulation behave differently when you set the styles of the component. So create renderer here, let Angular return different renderer based on the view encapsulation. So if you do, if you have a view encapsulation like default, it's going to return the default DOM renderer. If you have shadow DOM, then it's going to return the shadow DOM renderer, so that they know how to handle the styles correctly. All right. So here I just have my child renderer, and my child renderer accept the delegate renderer. I call this delegate, and I pass in the create renderer from the DOM renderer factory. And inside of here, I just a bunch of call the delegate. I just call the delegate. I have create element, append child, set attribute, set property, all that. Now, how do we use this? How do we tell Angular to use this custom renderer? So a custom renderer or renderer in that sense has to be provided on the environment injector. If you're not familiar with the environment injector, is the module injector. So like before in ng module, there's like a providers array. You can put stuff in that. That's the module injector. Now with the standalone is environment injector. So there are three ways. One is the providers array when you bootstrap the application. So that's one. Second way is to provide the renderer is through the route providers. So that's the new one, right? Route providers. And the third way is using the view container ref to create component. So when you create a component dynamically, when you render a component dynamically, that component gets its own environment injector, and then you can pass in the custom renderer for that particular subtree of that component. And then now the route provider is also cool because now you imagine you have different route. This route just use the normal DOM API, but another route maybe like something like markdown or documentation kind of route. And on that route, you do custom markdown renderer, what have you.
You just spoiled the one that I wanted. That's what I want. I want a markdown one. I love it. I love it. I love it.
Hi, Wilmer. Hi, Addie. Addie's giving you high props in the chat, by the way. So,
all right. So, for the purpose of this demo, I'm just going to use the Bootstrap application providers so that everything inside of our application from the app component is going to use the custom renderer. So we just provide the renderer factory too, and then we use our own custom renderer.
And real quick, so as of right now, your renderer is not doing anything special. It's just exposing renderer 2. It's essentially giving you an injection point that if you want to do things, this is where you do it.
Yep. Okay. And to prove that it's working, I'm going to put some console log here in the create element. Let's just say name.
Yeah, I typed that fast too.
Right. So now go back to the app. You see that this is right here. We actually running inside of our custom renderer, and it's that this div, that's the app parent, that's the h1.
Because you slapped that in the provider. Where'd you put it? How did you?
Yes, I slapped that in the Bootstrap application provider. All right. So now we know how to create it. We know that we can inject stuff inside of the renderer factory too. So you can have your service, right? You can have your own service. You can have your own injection token. Make sure that it is available to inject, and you can just do stuff with it. It's just like a normal TypeScript class. You can have this accept anything from the DI, from the dependency injection system.
Justin, did you have a question?
I want to pause really quick there because these are sort of things that I get excited about. I'm sure a lot of other people get excited. Like when you find this and you're like, okay, how can I get in there and do dependency injection and wire in there? And you do something as simple as like, then you have your console log that shows that it happens, right? I mean, I think that's an exciting moment. And you're like, yes, I found a way in. And now from here, the doors are open and like you're saying, you do whatever.
100%.
But just that moment is super exciting, right?
Yep.
At least for me as a developer.
100%. I'm so excited when I learned that I can do this, because ever since I know about the renderer, and I've known about the renderer for a while, and when I was working on Angular 3 or 3JS in Angular, I was like, oh man, I don't want to write like a completely custom renderer just for the WebGL. I really want to still use the DOM for something. But all I've looked on Google is just, you have to have like a new platform or something like that. You have to work with like a new platform to use this renderer thing. I'm like, no, that's just no. So
Or even like components, like you can make a component that does it under the hood, and you're like, well, I want to get lower bare metal than that, right?
yeah, true.
Yeah.
Yep.
Yeah.
So yeah, when I finally learned that I can do this, I'm like, yes. And then the rest is just here. Okay, so what we're gonna do is we're going to render some very basic stuff from the 3JS library using our Angular template. So if you're not familiar with 3JS, it is an abstraction over the WebGL API that allows you to build 3D scene easier. A lot of cool demo here, but don't get discouraged. I just want to quickly show this one. This one is so cool.
Okay.
Yeah, this one is a demo that allows you to pick a seat for like a concert.
Yeah.
Right. So this one right here, right? Oh, okay. If I pick this seat, this is what I'm gonna look. This is what I'm gonna. This is what my view looks like if I pick this seat.
Yeah.
Yeah, it's so cool. The idea is
in
so
the browser.
cool.
In the browser.
In the browser.
Not with Flash.
No.
That's awesome, right?
Yeah. So, all right, we're gonna start with going to the documentation of 3JS, and the first when you land on the documentation, you're gonna go to creating a scene. This is where they go through the basic of 3JS. We're gonna skip all that because I think you can learn it on your own. We're just gonna copy the final code of this section. Just copy that. Go back to my application. I'm just going to call this canvas component. And sorry, I tie a little bit here because.
Do you stream on Twitch, Chau?
I do.
Oh, thank God. I'm gonna find you, stalk you, and learn all your wisdom and have it for myself.
All right, so I don't think I have the package installed. Let me check package.json real quick.
Which package?
I do. Oh, you need 3. The package 3. Sorry, I didn't mention 3JS. I installed this. I prepared the repo ahead of time so that we don't have to run npm install on stream. So we have 3, and you also need to have the type definition of 3 package. All right, so we have the code that we copy, import it, and instead of using like the DOM element on the renderer, and we append that to the document body, I'm just gonna have my old canvas element. So just say canvas, and it's GL canvas, and I'm gonna view try it. GL canvas is gonna be element ref of HTML canvas element.
Vue had a cool question about the difference between the Vue engine and the renderer. Are they the same, or is the renderer part of the Vue engine?
No, the Vue engine is I guess the code name, like the old technology of the renderer engine of Angular. Now we have IV. To be honest with you, I don't know like what the role of a renderer back in the Vue engine day. I was not that smart before. And on the renderer, you can pass in the canvas element so that you don't have to do that. Right now, if I render my canvas component, I just take this one out, add canvas, and we can import that canvas component, save, right? Back to the renderer. Now we have something running.
What? That was so fast.
The one thing I may have missed there is where does the 3JS library is that brought in to basically say, hey, I'm using 3JS?
Yeah. It's right here.
Oh, I missed that. Okay, perfect.
Import. Oh, okay.
So yeah, just quickly go through this, like some basic to render to render a basic scene inside of 3JS. You need 3 things. First, you need a scene. The root scene is like a root component of the scene graph. You're gonna add stuff onto the scene to display it. You need a camera because the camera acts as like your human eyes, so you can look at the scene from different position of the camera.
If you don't give it a camera, does it have a default or no? Like it won't?
No, because you need a camera to render it.
Okay.
And last but not least, you need the WebGL renderer. WebGL renderer, sorry, unfortunate name, but it's not anything like the renderer we've been talking about.
I love it. Yeah.
It's the WebGL renderer. And then you create like
ignore this.
Yeah, you create your 3D object.
Okay.
And you add that object to the scene. And then you have to move the camera back a little bit. So imagine the camera by default is going to be as the center of the scene. But to see the center, you're going to have to move the camera back. You have to move back to look at the center. All right, and then we have the animate function. So like if you're familiar with like game development, game loop, we're just going to run something with the request animation frame API. And we just change stuff to animate stuff like little by little, frame by frame. And finally, we call render so that the render function gets called 60 frames per second on paper, technically. This is what we get. So this one, it runs a lot of times. Right. One thing I want to note here is that you can see that we can use Three.js as is instead of Angular. We don't need like any custom renderer or something like that. But if we look at the profiler and as they start recording, you see chain detection spikes like crazy. This is because of Zone.js patches request animation frame. So if you're using Three.js or any animation library inside of Angular, just make sure that you run outside of Zone or something like that. All right, so now we're gonna try to replicate this, but using the Angular template. First, I'm gonna move some of the stuff into like a Canvas service. I'm gonna make a service called canvas.service.ts. Canvas service. I'm gonna make this injectable.
Thank you, Fabio. Fabio said, "Great live. This is wonderful."
Thank you. We have provided in root. I'm gonna provide it in root so that I can inject it inside of my renderer. Now let's just copy the code. I will call this init, and I will accept the canvas element as HTML canvas element. Okay. Back here, let's grab all of this code and throw this in here. But I'm going to move the camera and the scene out to be the class property. Dot. This dot. I have to change that as well. This is going to have to be a cons. Canvas element. All right. We need this. Canvas element. Now we have a canvas service. Nothing too crazy. Just copy the code, move these two guys outside, and have an init function that accepts the canvas element. While we're doing that, let's also inject zone. We can run this outside of Angular. Now we don't have that chain detection errors. Not errors, firing crazy. Here, I'm gonna inject the canvas service. Service inject canvas service and call this canvas service on init that. And we should still see the same thing. Move the code to the service, nothing changes. Now,
but if we open the profiler, right? Like we won't
we won't see it. Nothing.
I wanted to prove it. I wanted to prove it.
Yes.
Also, Mateo said it is great to see Ciao persistence with 3. I have to use it soon.
Yeah, thank you. Yeah, use it. I'm not a Three.js developer myself. I just have a tool. So I just create a tool for you guys. I'm not creative to learn 3, to be honest with you guys. All right, so now we have the component, we have the service. Let's start with the renderer now. Inside of the service, what we can do now, we can say, hey, I can inject a service inside of here. Canvas service, I guess missing that, right? And we have the renderer accept this service. You can pass it in right here. Right now, for the name, what if we have something like, go back to app component, and now let's say the canvas will be our root. So whenever you wanted to render to the 3D, we're going to use the app canvas or the canvas component. And inside of here, we're going to put our custom element or custom thing that our renderer can handle. So Angular Air, I'm just going to call this NGA, I guess, right? And start with this. What is a mesh? And then we have box geometry. Let's start with these two guys. You see that now the Angular compiler is going to complain, saying, "Oh, what is NGA mesh?
It's not
I
a
don't
thing.
know.
Yeah,
Right? It's not a thing." And we don't have like directive a component that's actually provide these two components. That's why we need to use a schema called custom element schema. So this is the first drawback or con of using custom renderer inside of Angular at the moment.
What?
But-
Because you have to do that one line of schemas? That's the drawback?
Yep.
That right there? Okay.
Yep.
Yeah, seems minimal, but
Do you have the ability to define your own schema for your render?
Not natively by Angular. You have to depends on your editor, which I'm gonna mention at the end if we have time.
Okay.
If not, I'm just gonna tweet about it and tag you guys. Right. So now we have mesh and box geometry. Just to remind everyone, why are we using mesh and box geometry?
Mhm.
Mesh is the most basic object that you could have in 3GS. So mesh is like an object in 3D space that it has position, it has rotation, it has kind of like a coordinate system representation inside of the 3D space. But to give it a shape, you need a geometry. The geometry defines the shape of the mesh. You have box, you have torus, you have circle, plane, all basic shapes. And then you can also define a material. Material is like a texture of this mesh. So you can make it look like a cartoon. You can make it reflect light and all that. So we go with mesh and box geometry right now. And so now inside of my renderer actually see that already, right? NGA mesh and NGA box geometry. So we're going to do some string manipulation. So I'm going to say, hey, 3 name. The name starts with, right? It starts with NGA. We're going to do name dot slice -4. Or name. Let's console log this because I don't remember. Yeah, yep. Oh no, box geometry doesn't look correct, so just 4, I guess. Yeah, 4. So from NGA mesh, we extract mesh and box geometry out. Then we will grab the constructor from the 3 namespace. So it's just say 3 as any, and we grab the 3 name. And we say, hey, if we have the 3 constructor, we will try to console log it. And yes, we do have the mesh, the class mesh from 3, and the class box geometry from 3. So we just create a new instance, like 3 object with that, and we return the 3 object. Now, all hands will break loose. You can see a lot of bread in.
Yes, that's my favorite time of day.
Yep. So, excuse me. So you can see that the renderer, the Angular core now trying to append something, trying to add our objects onto each other. And you can already see that we can return absolutely anything from our create element. So you can have your own data structure. You can have your data model that works with your custom renderer. You just need to tell Angular about it. Right. Because right now, Angular calls the append child in my renderer, but my renderer is just now calling the delegate append child, and delegate is the DOM. So DOM trying to call append child, but doesn't have append child on the mesh object or the box geometry object. So what we need to do first is we go to append child right here, and we try to console log the parent and the child to see what it is. As append child gets called with the app root and the div element as the parent and the text. So that you can see parent child, and then we have the app canvas, and then we have the append child of mesh and the box geometry. So what we can do, just for this demo, we say, hey, if parent is object 3D, and if new child dot is buffer geometry, then we do parent dot geometry equals new child. To save times, I'm gonna add two auto checks. Is material, we're gonna add material. We append that. Else if child is another object 3D, then we do parent dot add new child. And here we can just return without going to the delegate. This is not my mesh, by the way. So here we're not nothing wrong now, but we'll have canvas. We're not seeing the canvas or any append child happens with the app canvas and the mesh. Remember when we put inside of app component, we want this, the interaction between this and the parent to happen so that we can catch it. Right now it doesn't. And the reason for it is that we're missing content projection inside of here. Angular content projection does create the things that we want to project, but we have to project it.
Why were we missing that? Like, why do we have to manually spell it out?
Oh, the entry content, you have to, because you want to project something inside of here, right? You want to project. So Angular, when Angular goes through the app component template, right? This is the app component template.
Yeah.
It sees app canvas. It's going to create the app canvas. It see NGA mesh, create the NGA mesh. You see the box geometry, create that. Does all the interaction with this. But because we don't have the ng content tag inside of app canvas, Angular stops right there without trying to project this NGA mesh between our canvas. So without this, Angular just stops. But now we have this in. We're gonna see some more code. So right now, go ahead.
In your renderer code, you're basically saying, look, I've got some things that are not DOM related, so I need to do some checks in there to make sure that we're not delegating the DOM related stuff when it appends child. We're short circuiting and say, don't do anything because these are not DOM related things. Otherwise, if they are DOM related things, go ahead and do your DOM stuff.
Yep. So now, because I put the ng content between the canvas element, now Angular will try to append the mesh that is create onto this canvas element. Now, because this happened, I can now check for, okay, if my parent is the canvas, is an HTML canvas element, I can use the scene in my canvas service, because I would assume if the parent is the canvas element, then it will be the root element. So I'll go back to my renderer, and right here, I can say, hey, if my parent instance of HTML canvas element, I can just do this dot append child again. I will recall my own append child, and I'll pass in the scene as the parent and new child. Now we save, and we go back here. We see that's on the scene right there. That's our cube. That's the white thing. So we have something working. So let's remove the spinning cube, the green one, and continue working on our mesh. I'm going to remove this one. I comment it out. Go back to my app component. I'm going to add my old mass basic material inside of here and save. And that's our cube right there on the scene. We can see that with the scene object, the children is the mesh. It has the box geometry and has a mass basic material. All right. So that's first step done. We can append stuff.
So you're basically like, can you go back to the HTML real quick, or the
yeah.
So you're basically making your own DSL, domain specific language, right, for things like mesh and box geometry, where you can make these HTML like element, names, tags, and then your render is going to parse that and be able to map that essentially to 3JS objects. And so that's essentially you're building here, and then you're using your renderer to render these type of tags essentially from line. And GDE mesh.
Yeah.
So instead of creating necessarily like components for those particular pieces, you have that DSL of, hey, when I see one of these, I know what that translates to in terms of 3JS to be able to do that mapping.
Yep. And that guards me from breaking changes from 3JS itself. Right? Because if 3JS updates something in a new version, my consumers update to that new version, they have to fix the breaking changes that they use on the elements themselves. I don't have to go back to my component or wrapper components and fix that and then have to release a new version.
Right. So when they go from mesh to mesh 2 or private mesh 3,
they have to fix it. Yeah.
Right.
And one thing that is really cool when you use the renderer is that you can do something like this. Right. I have a mesh. I can view child this mesh, and it is element ref of 3 mesh. And that is my mesh element. So Angular core doesn't really care about your element at all. It just gives you what you give it when you what you return from the create element.
So extrapolating that out, you have your own set of tags for Angular 3, which I'm assuming aren't prefixed like with NGA. That's just your representative example here. So I don't know if it's NG3 as a prefix or whatever it is.
Yeah, it's NGT.
NGT. Okay. So it could be Angular 2 or 27 or 34. Okay. Anyway, so you're using that as the ability to say, hey, I'm going to intercept that message and render it out. Did those also then accept or have different like inputs and what have you on them? Or how did those work?
We're going to start.
I'm assuming not everybody wants just a white square.
Absolutely.
Oh,
absolutely. So now let's start.
Then you should have just called a white square.
So let's have our material accept color, and I'm gonna give it like hot pink. And let's have our mesh accept a position. I'm gonna move it 1.5 point to the right, so the x-axis. I want to move it 1.5 point to the right of the x-axis. We have to make these work. Go back to the renderer. So the color was the attribute binding, right? Color without any braces, brackets. So it's gonna go into the set attribute. And here I would say, hey, if L is material, I would just do L name dot set value. By the way, this is very basic, but you're gonna have to, inside of my library, I have to handle a lot of cases. Right now, you see now that hot pink color that we set on the material. Next is the position. The position, is now a property binding because I bind it to an array. I have to go to set property. Say, hey, if L is object 3D, we say L dot L name set again. But this time I'm gonna spread the value. I'm gonna assume the value is always gonna be an array. Now you can see that the object is moved to the right. So now we have that. What we can do is now we can use the power of the template or declarative programming to have two mesh. We'll call this mesh 2. And I'll move this one to the left, and we'll give the color of orange. You have two mesh. See how powerful that is? It's very declarative,
So
right?
awesome.
Yes.
You can also make this make this a component, and then you can just reuse this component. And the component can have its own inputs. So you can pass color inside of it. You can pass position inside of it. It has its own state. So maybe you can hover over it and it changes color or something like that. Right, so a component can have its own state, and right away you can put a custom directive on here, my custom directive, and inside this custom directive, and you do inject host element ref, you will get the mesh element, like the mesh object itself.
I just want to pause there really quick and just give big shout out to Angular, right? The framework, the platform itself. Like this is, these are some of the things that are amazing, right? That maybe we don't see or take for granted, right? The fact that you put that, template ref name mesh and mesh 2, and you use the view child and you just declare the typing of 3 mesh. And now you have access to this. And that came to us from the Angular platform, provides that infrastructure that we can do stuff like that with very minimal effort. And that's it's the stretch and breadth of Angular as a platform that sometimes just gets glossed over. That's like all the stuff that it provides us and then allows us to do. It's amazing.
Yeah, this is kind of like pushing Angular to the limit, I guess. And by the way, okay, last one before we stop. I think we're over the time. But last one is that we're missing the animation, because I kind of want to show that. So to handle the animation, simple. We're just gonna have a, I guess, animation object here. Gonna be a record. Right. Actually, let's do a map of string and a function. That. And inside of my animate function, I'm just gonna loop over that and call the animation. Right. So now I want to do is that I want to say, hey, I want to do before render. Let's say on before render. This is custom custom event, right? And I want to pass in mesh. And here I say on before render. 3 mesh. I say mesh dot rotation that and the y. It's gonna complain. By the way, this is limitation of the Angular compiler. It doesn't recognize this mesh as a 3 mesh. It just knows that it's an HTML element. So I have to do this. All right, same thing with this guy. And yeah, it's gonna be mesh 2.
Is that putting an Angular template any on it? Like we put a TypeScript any on it, but this is Angular template any on it.
Yeah. Right. So that is event binding. So we're going to go to the listen method on our renderer, and we say, hey, if target is object 3D, and we also check if event name is before render. Right, we're going to call this before we render the scene, which is we're going to do is const the ID. Actually, we're going to do this dot canvas service dot animation. We grab the target dot ID UUID on here, give it a function. Oh, it's a map. Sorry, it's a map. So we can do a set target UUID and the function. And the function would be callback. It passes back the target. And the listen function can return a cleanup function so that we can clean up our animation when this component is destroyed. And let's just do that for now. Gonna work? It's working. All right. So what if box is too boring? Let's have some donuts.
Too boring.
Let's have some donut. And that is our donut. Maybe we can change this to icosahedron geometry, and that is our thing. I'll be quick right here. So let's add some light.
Oh yeah.
Spotlight. I'm gonna put this 5, 5, and 5. With this is a pawn light, and we're gonna put this like directly opposite of the spotlight. And we're gonna change the material to standard material, which is a material that can reflect light. And this one is different material, I guess. Now we see it is a 3D scene. All right,
Yay.
so that
So you
concludes
basically
my
created-
demo.
You created this render, you hooked up all those pieces, you know, to do that, and you provided this DSL that then essentially opened the door for you to embrace the 3JS API.
Yeah,
And that's what you just did there, is like the 3JS API has all these different, you know, geometries and things like that.
Yep.
And because you built that render in that way, it can parse that, make those objects. Yeah, it's awesome, man.
Yep. Yeah. So to use this, you don't have to build the renderer yourself because I already built it. It's as angular3js.netlify.app. So
Yeet.
Nice. And it's got a shield icon. There you go. It's
Yeah.
official when it has a shield icon, right?
yeah. So that concludes my presentation.
Fantastic. Hi, Mark Texan from the Angular team in the chat. And also, Lars, he was asking about signals. We actually have a show coming up with the amazing Manfred Steyer on the Angular Renaissance. So check that out if you want to hear our thoughts on signals. But Chau, I am humbled by your wisdom. This was incredible. By far the most thrilling demo I think I've ever your live coding skills, man. Like your fingers like sizzle from the heat. Like
It's cold down in the basement. But it's okay.
all right. So I know we're over time, but Chau, do you have anything other than your incredible library to shout out? Any picks for you today?
Yeah, actually, I want to pick a person. He is Ryan Coniato. For his current collaboration, I would assume there's a collaboration between our Angular team and him on the signals. And by the way, Ryan Coniato is like a down-to-earth person. He's genuinely just want to see the web moving forward.
Mm.
Yeah, so no
That's
beef.
awesome.
Yeah.
What's up, Broco?
Yes, he has worked with the Angular team. He actually did a YouTube stream, or I don't want to say just YouTube. He did a stream with a couple of members of the Angular core team, Alex Rickabaugh and
Power, yeah.
Aww. I Steve Whitman. I think I got all the names. Steve Whitman just said awesome, Chau. And you're getting mad props. Well, thank you so much for this. Seriously, anytime you want to like dribble some code on the Angular airs, we are willing to dribble with you. So thank you so much, Chau. You were amazing. I think that's a wrap, everyone, but we will see you next time. Bye.